Okay, so this is the first Ansys Fluent project for fluid mechanics. The first step will be to Poiseuille flow. So the first step would be to take a fluid flow fluent, click and drag it over here. I will not be creating a new one for the purposes of this video, but I'll just be going through what I have already done for the project. So once you drag it over here, it'll give you this little square pop-up. And the first step would be to click on geometry. So you click on geometry, it'll bring you up to here. And then what you're going to want to do is you're going to want to hit sketch. It'll bring up a plane in which you will create a rectangle. For this one, I did 10 millimeters in height and 1500 millimeters in length. And then once you switch back to 3D mode, it will automatically create a surface here. And that's it for geometry. Once you come back to Workbench, you go to Mesh, and then it'll bring up this piece of software. And then from here, what you're going to want to do is for each side of the rectangle, you're going to want to create a named selection. So as you can see, I created an upper wall for this one up here, lower wall, inlet, and an outlet. And that name selection is just up here, name selection, and you can do that. And what you're going to do is you're going to come over here to the outline, mesh, right click, insert sizing, and then I'll bring up this little sidebar down here. For the first one, you're going to want to select both the top and the bottom, so both your upper and lower wall, and then hit apply here, and then it'll say two edges. You're going to want to change the type to number of divisions, and then for this one, I did 2500. You're going to want to put no for capture curvature, and the behavior you're going to put hard, and then you hit generate. And then once that goes through, once it's running, this face will turn green, and then when it's done, the green will go away. You will do the same thing for both the inlet and the outlet. Number of divisions, hard behavior, no capture curvature. The only difference is I did 50 for the number of divisions on the sides instead of 2500. Then what you're going to want to do is you're going to want to come up and then face mesh. You're going to click the entire face, and then no further changes needed down here. Generate. And then once it's done, you'll be able to come up in here. If you zoom in, you'll be able to see what the mesh looks like. Once you're done with that, come back to Workbench and go to Setup. Setup will bring you to this piece. And what you're going to want to do, you're going to want to go to Results, Residuals, make sure all of these are 1E minus 6. Hit OK. And once you do that, you want to go here to the outline view, Materials, Fluid Air. I used air for this project. I used density 1 and then viscosity 0.0001. And you would hit create change and then close. Then you come down to boundary conditions, inlet. You want to make sure when it opens here, you want to make sure it says velocity inlet here for the Poiseuille flow. Then you just insert your velocity magnitude. I chose 0.04. So that's what worked for the Reynolds number. other conditions are needed for this one. And then you go down to reference values. Make sure your reference values match what was in there. You come down to run calculation, right click, initialize and calculate. So you can do that, or you can hit initialization, then it'll run the initialization, and then run calculation, calculate, and then do it. I just find it easier to do it in one step. So once that's done, you can come back to Workbench and then go to Results. Once you pull up Results, it'll give you similar to what this looks like. So it'll give you this in here. What you're going to do, you want to come up to Location, Line, and then Midline. And you want to create another one that says End Line. When you create the lines, they'll give you this little sidebar here. You want 0.1 to be half your length here, and 0.2 to be half your length, and then your 0.2, this second value, to be your height, the entirety of your height. And make sure your samples are 100 on end line. It'll be the same, except it is right before your end, so not quite. Then the height, then the developing flow. I just used 0.09 for this case. Once you have your lines, you go up here to contour, and it'll pop this up to get it in this view. Because normally it'll look like that when it pops up. Way to make it come across. Definition, click horizontal, appearance, fixed, apply. And then that'll fix it, make it look nice. Come over to chart, chart is up here. This one. I'll pop this up. For data series, you're going to want to create a new one. Make sure midline, name midline, location midline, and do that for all three lines that you made. X-axis, you want to change to velocity U. Y-axis, you want Y. Once you hit apply, it'll pop up this chart. This is what the velocity looks like for the Poiseuille flow, parabolic. As for the other flows, a lot of the steps are repetitive. So for Couette flow, the geometry and mesh portions are the same. The only things different is in setup. Instead of velocity inlet, you're going to want right click edit. And you're going to want to make sure, okay. You're going to want to make sure you change this to pressure inlet. I pull it up here. Precision again. Gonna make sure the same thing, fluid air. For the Couette flow, I decided to use density 1, viscosity 0.001. Boundary conditions, you want to make sure inlet is pressure inlet instead of velocity inlet like the other one. And the other change, you want to go wall. You want to click on your upper wall. Because Couette is a shear flow, you need to give your walls some velocity. So the default will be stationary wall, no slip. You're gonna want to change to moving wall and then give it a speed. I gave it 3 meters per second. You're gonna do the same thing, run the calculation, come back. The results for the Couette flow are going to look a little bit different than the Poiseuille flow. It's going to be a linear instead of parabolic. Let me show you. All right. Once you go through, make your lines, do your contour. It'll look like this. And then your chart, once it loads in, it's going to look linear instead of parabolic like the other one. So it's not wanting to show, but like I said before, instead of being parabolic like this, it'll look linear. And for the hybrid flow, you're going to do the same thing for geometry and mesh. And then the setup, you're going to want to go back to velocity inlet, but you're going to want to keep the upper wall velocity. So you're going to have both a velocity from the inlet and from the upper wall. Other than that, everything else stays the same. Run the calculation, and it'll be a mix of both a parabolic and linear. So it'll be kind of more flat-lined in nature than the Poiseuille flow, but still parabolic, more so than linear. And then that is all I have for you today. Thank you.